Pharmacodynamics is up first. This is the interesting stuff, at least to me. It's chapter 3 in your text, so I'm kind of skipping 2. We'll come back to 2. But ultimately, when I talk pharmacodynamics, this is what we want to look at the interesting stuff, at least to me. When we put a drug in our body, like, what does it do, right? What does the actual drug do? Where does it go? What does it do? What effects does it have? And that kind of stuff. When you double fist in Dr. Pepper's and you're getting, although there's a diet, he's mixing diet in there, so it's not super sugary. He's trying to, control a little bit. As he works up to say something else, maybe alcohol. We've all seen drunk people, I'm sure. You may have even been a drunk person, and we've seen some of the effects that alcohol has. Well, what physiologically, when we put alcohol in a body, what makes you act like this? What makes you act with no or less inhibitions and blurred vision and struggling to talk and do those kind of things? That to me is kind of the physiologic part is the dynamics part. All right, so the book does start with some terminology that you're going to hear when discussing drugs. These will be more important for you just to know the terms. So when you see them as you read or see them in a sentence, see them in an answer choice, you'll know what that means and be able to pick them. I'm not going to make you define these. The first 3 all kind of have the same general outcome. We're creating a larger effect with 2 things than just 1, right? So additive, yeah, that makes a sense. Summation or summative effect, sometimes you'll see that. If you really want to get in the weeds, you can look at the additive. It has the same biologic response, so these have the same mechanism of action. These are different mechanisms of action, that kind of stuff. Don't worry about defining those and differentiating those. I'm not really that that important. I don't think it's that important to do that. Oops, what just happened? I just clicked something that I shouldn't be clicking. All right, let's go back here. There we go. I don't know what I clicked and got off there. Sorry for that. All right, so I guess I want to click forward. There we go. Synergistic is that third one. Synergistic is the third one that, again, we're getting a greater response with a couple different substances. And I think synergistic a lot of times is with a drug and then another kind of substance, whether it's a neurotransmitter or alcohol. So for example, here's a good example. If we take pain medicine, narcotic pain medicine, along with alcohol, that's a no-no because it has a synergistic effect. We did talk about agonists and antagonists, and so there's a blocking kind of situation with that antagonist effect. And then everybody, you've heard of placebos. When we talk about research, you talk about placebo groups, and there is a placebo effect. The book talks about that. Book talks a little bit about tolerance and knowing what that is. Dependence and addiction, I don't think are in there, but you've heard those before, and sometimes you use them. So know basically those kind of terminology. I got one more screen of terminology for you that's not as obvious. Like you don't use endogenous or exogenous in your daily lives. I don't expect you to, but knowing that this is from inside the body, this is from outside the body, and then there's these other terms that are in the book, affinity and efficacy, that's defined within the text. And then especially as you get into that receptor theory, I put SpongeBob up there, blah, blah, little GIF, mainly because receptor theory to me kind of sounds self-explanatory. It should be, and I'm just taking it for granted now. If it's not, if you don't understand the concept of a receptor and certain things that fit into the receptor, you need to. Figure 3-2 on page 45 is perfect, man. You can look at that picture and then read that little description. That little description is way better than the rest of the text. So definitely read that. It addresses affinity and efficacy and some of those other things. So those are where you can really get some good info. All right, now we get into the more, like class specific, like this is the meat of our meal here. And so the first kind of pharmacodynamic concept is this dose response. How much of a dose and how much of a response, and we start to do that. You'll see these graphs a lot. On the bottom, you see the amount of the drug that's being given, and then on the vertical axis is how much of the response all the way up to 100% response. And so you can see drug A If you take about 10 milligrams, you're going to get about 50% response. If you want 100% response, you may have to take, looks like about 15 milligrams. Comparing to drug B, if you want that same, what is called a ceiling effect, right? That point where you're not going to get any greater response no matter what you take. Then if you want that maximum response for here, you're going to have to get about 23, 25, 24 milligrams compared to the 15 milligrams for drug A. So it's you can compare drugs, you can see that, make sure you have an idea of the ceiling effect. If I take 25 milligrams of drug A, that's not going to be any better than 15. So that's where that ceiling effect part comes in. And really, when I say compare drugs, the easy comparison is potency, right? When you compare different drugs, is potency. How much do you need to get the same effect? Alcohol is usually a good example when you talk about, say this is like a 16-ounce beer, and then we're going to go 2 shots of whiskey, Jack Daniel's whiskey. These are probably maybe a 4 ounce, 4 ounces in each. You got 8 ounces here, and you got 16 ounces here. It's the same general amount of alcohol, and so you got a much more potent in the Jack Daniel's as it is into the beer. When you look at the graph, you can kind of see the same. Now we're looking at milliliters in this graph right here, but it's the same thing. When you're looking at drug A, you need about 10 milliliters for 100% response, as opposed to drug. We'll go with C since he's still on there. You need 100 milliliters. So you go 1 or 10 to 100. That's a big difference, and so obviously drug A would be a lot more potent. The other thing that this graph is good about showing, and I haven't really responded to it yet or mentioned it, is this ED50, and that's in your text as well. That's an important concept that you definitely need to know. And that is really, there's a couple definitions. Your book talks about it. For a long time, I used this second bullet, almost exclusively. We're getting a specific response, whatever response we're looking for. A specific response in half the people that take it. More and more, I've seen both of these. I still see both of these, but now I see more of this dose here, or this definition, where it's producing half of the response. So if we're talking about pain control, is it complete pain control, or just is it partial pain control, right? So either one of those will be fine as we talk about those, but it's just that 50%, that half kind of effect that we're getting to. And usually I use when I talked about potency, I use the ceiling effect. Usually we don't use the ceiling effect, the maximal effect, to compare drugs. Usually it's that, all right, what dose is getting us 50% of the people or the response that we're actually looking for? And so you can see that drug by drug A is definitely the more potent drug in this group. The next thing that we look at these dose response curves for is really, and this is now we're going to stop comparing different drugs. Now we look at the same drug and we look at the safety, right? So how safe is this? The toxic dose, right? The TD50, and that's in your book. It looks like on page 49 is, where do we start getting some pretty significant adverse effects in about 50% of that population, right? So we want to try to figure out, where does that toxic effect start to take place. We want, if we're looking at 50% of the population getting the actual intended effect, we want more than 50%. We'd like to beat it up, close to 100. So what is that? Can I get most of my ceiling effect before I start getting a significant toxic effect? And we can look at that. And that's when we compare the ED50 and a TD50, we can get like a therapeutic index, and it's just a simple ratio. Given the 10 milligrams versus 3 milligrams, you get a therapeutic index of 3. That kind of gives you an idea of how that is. If I change the values a little bit, if I go from 10 milligrams to 100 milligrams, that gives us a bigger ratio, right? And so that's 10 now. So ultimately, if you look at, we'll look at the first example. really, if you think about, all right, I got to have 10 milligrams to get 50% effect, to get a basic effect. If I get 30 milligrams, I'm going to start getting some significant toxic effects. So my range right here, my error range is about 20 milligrams. I don't have that much range as opposed to these two. If this is my therapeutic index, man, I got 90 milligrams worth of work here, or of milligrams of cushion, before I start getting enough toxic effects to start really worrying about it. So make sure you know that therapeutic index gives us the relative safety. It is the ED50 compared to the TD50 or even the LD50, right? So the lethal effect. Most of the times we don't like to do that, especially in humans. We don't really do a lot of research on how much of a drug is going to kill people. That's primarily done in animal research. So that's the hard part about when we're dealing with humans. We don't want to kill them, but we're looking at, so if we look at a therapeutic index and you're looking at a lethal effect, most likely that's from an animal study. If we're looking at the therapeutic index with the ED50 and a TD50, that may be more of, all right, we're doing now human trials, and at 50 milligrams of this drug, we start to get some pretty significant adverse effects that the manufacturer or any clinician wants to stay away from. So where can we stay? We want to get as much of the response as we can, but if we start getting up here, the more we get, maybe we'll tolerate a few toxic or side effects, but to get up to that ceiling effect, or as close to that 100% as we can. The other way to say this is basically in this scenario right here, if we're looking at ED50 versus LD, the lethal dose, right? When you look at those two, basically because it's a 10, right? That means you need 10 times of the normal dose of that drug to start causing death in about 50% of the subjects. Ultimately, as you can see, the last example I had was a therapeutic index of 3. This has a therapeutic index of 10. The higher the number, the more safe the drug. So however you want to describe that is fine with me. The final concept that I'm going to talk a little bit about is this dose response curve. Sorry, no, time response, but it kind of gives an idea of once we take a drug, this is time in hours down here, when do we experience that onset of action? How long is that? And then it kind of comes off where the effects are gone. Still in the blood flow, but it's, our effects are gone. The book talks about this in that page 50-51, it talks about a latency period where you take it and it hasn't really worked yet. And then some drugs really need a period of time to get blood levels to a significant level. You'll also see this concept, you don't have to know this for my class, for that kind of stuff, is these terms like area under the curve, minimal effective concentration. I'm not going to, we're not going to be pharmacists or, chemists that are creating drugs. But ultimately what you will see this in some literature that we talk about and that we look at, is that how much of this is from the onset time right here to the time where it goes off. So how much area is under here, and different drugs may have different, come on, get my other pen. Different drugs may have different, windows. So this may be a pretty short, goes up real high and then kind of tapers off and doesn't last very long. This may take a long time to get there, but it lasts a little bit longer period of time. So the final concept is, I've kind of stole this from the pharmacokinetics, is this concept of half-life. But I think as we're talking about time response, dose response, how it works within the body, I think the half-life is important to kind of put in here. But it's ultimately, as the blood concentration goes up, how long does it take to cut that back in half? Because your body immediately starts metabolizing it, getting rid of it, trying to get it out of your body. And so that's kind of an important important number. This half-life, how long is that, is important for telling us how often we should take it. And so I gave you an example here. This is naproxen sodium. If you don't know, that's a leave, and we take those typically every 8 to 10 hours, right? Our half-life is, every 12 to 15 hours. And you can kind of see the difference between ibuprofen. You guys already know that when we talk to our patients and we tell 2 leave in the morning, 2 leave at night, and you're done. If we're doing the equivalent of ibuprofen, we're going 4 ibuprofen 4 times a day because we have to do it every 4 to 6 hours. So, all right, I'm going to stop there and kind of